global warming, even though obviously there's a large amount of natural variability and fluctuation in here that we can't explain from climate change. So that's just New York, to give a local example. What about droughts? So this is a picture of Lake Mead outside Las Vegas, the opposite of floods and droughts. Outside Las Vegas, a lot of people depend on this reservoir for water. This is a few years ago. You can see how low the reservoir was compared to its historical average, which was up here. And the West has overall been in drought. California, by the way, is still in drought despite all the flooding they're having. Most of the state is still not out of the drought. It's amazing that they can have those extremes at the same time. They have dams about to break or spillway at least about to break in Lake Oroville due to flooding at the same time as most of the state is still in drought. So this is a prediction. So droughts are actually more complicated because they're the absence of water vapor. So the fact that water vapor increases doesn't affect droughts in the same way, and they're strongly affected by the atmospheric circulation. A drought is by definition a thing that takes a long time to happen. You can't have a 2-day long drought. It wouldn't make any sense. So the atmospheric circulation has to reorganize itself to have really big droughts, and there's still a lot of uncertainty over much of the world as to what extent that's happening. But there are some things that we can say. So this is a prediction done by some colleagues of mine at Lamont-Doherty Earth Observatory, which is part of Columbia Laboratory across the river from here in Rockland County, where I work part of the time. And my colleague Richard Seeger and others did a study based on all the latest, greatest climate models showing predictions for the southwestern North America, which is the southwest US and northern Mexico, which is already a dry region, very water-sensitive region. So these are changes compared to historical average in precipitation minus surface evaporation. So the precipitation is what falls, evaporation is what evaporates again from the soil, and the difference is what goes into groundwater or into rivers. So this is what matters for people. And you can see that it's not doing much up to present. I mean, the prediction is not that whatever droughts they've had so far, you can't attribute too much of it to climate change because you just see mostly wiggling around up to about now. But then it starts to go down, and this range is due to different models. So there's a range of different models, some dry more and some dry less, but they all get drier. So this is one of the regions of the Earth where the climate models tend to agree that the circulation changes in such a way as to dry it out. There are other places where the models don't agree. Just like you saw all the different reds and blues on the rainfall map. There are some places where the reds and blues, in this case the reds, which are lack of rain, all line up. There's other places where they don't. So that's one of the factors. But so here the prediction, unfortunately, is somewhat more confident than it is in some other places. The other place, I'll tell you the other one in a minute. The other factor, though, is that as it gets warmer, whatever rain falls, the water that's in the ground evaporates more quickly because it's hotter. And that's a direct consequence of the temperature increase, which is one of the things we understand the best. So that contributes to making droughts worse globally. So for example, the California drought, Seeger, these same people who did this report did a study of the current California drought a year ago when it was already several years old. They came to the conclusion that the absence of rainfall in California over that several years was not a consequence of global warming, that it was just a result of natural fluctuations in the climate. However, the fact that it's hotter means whatever rain does fall evaporates more quickly. So the drought in the soil, even though the lack of rainfall may have been natural, but the actual drying of the soil was exacerbated by the warming. So there's both factors contribute to the droughts and to the hydrologic drought, which is the absence of surface water. And some of those are more uncertain and some of them are uncertain. I don't have a slide on it, but I want to just mention the other place that the climate models are quite confident that the drying is getting more severe is the Middle East. That's the other hotspot that all the models agree is going to get drier as the climate warms. That's very unfortunate because it's a very water-sensitive region and also very politically troubled region where water is one of the factors that drives instability and conflict. So that's scary. What about hurricanes? I work a lot on hurricanes. So this is a satellite image of Hurricane Patricia. This was in the Eastern Pacific in 2015, and it was the strongest hurricane ever measured in